This is Stephen from EDRMedeso UK with a video on introducing you to a simple pressing simulation using ANSYS Fluent in the materials processing workspace. So the ultimate objective of the simulation is to look at a fluid being pressed into a fixed mold. So I'll just play the animation here. And this is the result of the simulation. You can see the fluid adopting the shape of the mold. So I'll just play that through one more time. Okay, so we're going to be using Fluent, but before we go into the Fluent workspace, we're just going to look at the mesh. So I've done this in Workbench meshing. It's pretty straightforward tetrahedral mesh. I've got some curvature on the details here of the mold. And you can see that the fluid zone here is actually using quite a regular, uniform tetrahedral mesh. The reason for that is that it's very difficult to anticipate where to refine the fluid in one of these simulations. So we're actually going to be using solver adaptive meshing. So that's why we've started with relatively coarse mesh on the fluid itself. Okay, so let's look at the name selections first. So we'll cover the bodies here. We've got the fluid, we've got the fixed mold, and we've got the plunger. And the face boundaries are the plunger contact. So that's all of the faces on the plunger which are going to contact the fluid. All of the other faces I've just put together in one name selection called plunger other. Same with the mold. So again, the faces that are going to contact, I've called them mold contact. And again, all of the other faces I've just gathered together in one selection there. Then we have the free surface of the fluid. And lastly, two symmetries for the fluid. Okay, one and around the corner here. Okay, and yeah, you don't need to have symmetries for the plunger or the fixed mold. Okay, so once we've got our mesh, we can export that into the polyflow format. So select mesh, polyflow input file, and press the export button and you can write out your mesh file. So we can then go into the Fluent workspace. To access that, we start up Fluent as a standalone session, so outside of Workbench. And below the regular operating modes, meshing and solution, you've got the materials processing workspace. So select that and fire up your Fluent session. Okay, I've got one started here. So this is the interface where effectively we have the polyflow solver embedded into the Fluent graphical user interface. So it's a little bit different from the regular solver, geared up specifically for polyflow type simulations. So let's press the polyflow mesh button and import our mesh. Give that a second or two to load up. Okay, so that's our mesh imported successfully. And the first step of the process is we're going to use a template here. So I'm going to click the template button, and this is going to set up the majority of the outline view, all of the different tasks that I need for this specific type of simulation. So I've got a few options here. It's brought in a 3D tech mesh, so it knows there's a number of options for this. Internal flow extrusion, and we're going to select pressing. Okay, so now I've got to answer a few questions here. Number of fixed molds, well, that's this one here, so there's one of those. Number of moving molds, that's the plunger. Again, one of those. Duration for this simulation is going to be 0.75 seconds. And we have the option to run a thermal CHT analysis. In this case, we're not going to do that, so we'll leave those boxes unchecked. We press apply, and you see my outline view now is populated with all of the tasks that I need to run this simulation. And as you can see, some of the tasks have green ticks next to them. That means they have all of the input that's necessary. Doesn't mean that the input's correct. You've still got to go in and check that. And the ones with crosses means there's empty fields in there, so you need to go in and put some input. So let's look at general first, just to review the general properties here. So the mesh unit, the box size, always useful just to check that to make sure that the scale is correct. And the type is 3D, calculation type transient. You can put in your own task name if you wish, and you've got the duration. And then you've got some more additional physics options here. In this case, we're just going to include the inertia effects. So now we can move on to the fluid definition. And it's just got the default fluid in here. There's a couple of changes I'm going to make to it. So I'm going to change the density. Okay, and I'm going to change the viscosity law. Well, it's actually going to be constant, so I'm just going to plug in a value there. So that's my fluid setup. We can move on to the cell zones. And you can see it's set up 3 for me. So I've got the fixed mold. This is straightforward. The fixed mold really isn't doing very much, so all it needs to know is which of the zones it is. So I select the correct one. Okay, then I move to the fluid zone. Again, straightforward. I just need to select the appropriate zone. Okay, and then the moving mold. There's a few more inputs on here because we have to define the motion. So our moving mold, we called it the plunger, so select this. By default, it's expecting a translational velocity. We're going to use a translational force here, so I just select this. I need to put in the mass, and I can limit the displacement of the plunger. Okay, so it's got that maximum displacement. And then I can put in, if I want to, I can put in an initial velocity. In this case, it's going to be starting from 0, so we can leave that. But I do need to put in the translation force. So it's moving down the y-axis, and the orientation is negative. So I just key in my value of negative 10 newtons there. So now we can move on to the boundary conditions, and you can see it's set up one of those for me. All of these pressing simulations will have a free surface, so it knows that I need to have one of those tasks there. So I can just select the zone. Okay, it's free surface. Okay, and you see the top level task is still indicating that there's input required. So if I just click there, it's telling me that, okay, I've got 2 more zones and they don't have any conditions applied. So I just have to create those. So I'll create the zones by pressing the new button. Give it a name. Specify the type. And I'll just go ahead and select the zone. Okay, and I just need to do that one more time for symmetry 2. Okay, and set the type and the boundary zone. All right, now we can move on to the contact boundary conditions. You can see I've got 2 tasks here because that free surface, it's going to contact with the plunger and then it's going to contact with the mold, hence my 2 contact boundary conditions. So we'll click the contact with the fixed mold first. So it's asking for the fluid zone, and that's the free surface attached to the fluid. And then it's asking to specify the contact boundary. So we called that mold contact. So it's this one here. Okay. There are some other settings here which often you don't need to adjust from the default, but one of them that you might adjust is called the penetration accuracy. Now what this figure means is as the plunger is approaching and pressing on the fluid, if the free surface penetrates into the mold surface to a distance greater than this, then what the solver will do is it will reject that particular time step, and it will go back and it will start the time step again with a smaller time step. So it's just a way of ensuring greater accuracy. And as I say, you can use the defaults. Generally this is okay, but you may want to tweak this. In this case, we'll loosen that up a little bit, and then we can do the same with the moving mold. So select the zones, free surface, okay, mold zone, and this is the plunger contact. So it's this face here, and then we do the contact condition again, and we'll adjust that accuracy input there. So now we can move on to the mesh deformation. This is quite straightforward. It's just asking for the zone which is actually going to be deforming. So that's the fluid zone. And we're done with that setup. And the final is the adaptive meshing. At the top level, there's a few inputs here. Number of steps. Again, generally the default is okay. What it means is this is the number of time steps that will run through before it does an adaptation step. So the larger this number is, the less mesh adaptations it's going to perform. If you have that set to 1, then it's going to do the adaptation at each and every time step. So it's a reasonable value, but you can increase that. We'll set it to 5. It just depends on the case. So it's another variable that you might want to experiment with a little bit. So now we'll move down to the condition here. All right, so you can have multiple conditions. We've just got the one here. So it's asking for the zone again, so that's the fluid zone. And then it's asking for the surfaces of contact. Okay, so our fluid zone, it's going to contact both of these, the mold contact and the plunger. All right, so this is telling it where the adaptation is going to be occurring. We have a couple of options for the method. We can do that by curvature, or we can do it by distance. It really depends upon your case. If there's a lot of curvature, you might choose this option, or distance. We're going to use distance in this case, and you have to specify minimum sizes and maximum sizes. So we'll do that first. This is really based upon your mesh. So we'll key in the values. And we'll put in the maximum size. Okay, so that's set where we want it to be. And then we've got these distances here. The distance is the value below which this size is applied. And again, the reverse is true of the maximum distance. That would determine when the maximum size is applied. Okay, so we'll set the minimum distance. Okay, and that completes the setup of the adaptive meshing. So we can then go on to the solution, but just before we do that, I'm just going to open up the solution tasks here. If we review calculation activities, again, generally you can start with the defaults here, program controlled. In some cases, you may need to tweak some of these settings. For this case, we're going to look at the convergence criteria here, and we're going to change that to user specified. So in this case, I'm just going to tighten up the convergence tolerance here, so we can guarantee a better solution. And with that done, we can move on to run calculation. And before we hit the calculate button, I'm just going to run a check here. Just going to go through all of these tasks just to check that there's nothing missing and the setup is valid. And we have the message that we're ready to start the solver. Okay, so if I hit the calculate button, the Polyflow solver starts up and all of the output is in the transcript file here. And then you have your convergence monitors in the third tab here. Okay, this particular simulation on my machine takes around 23-24 minutes. So I've got a preloaded case here. I'm just going to switch over. All right, so this is the simulation that's been run. So you can see the fluid has been pressed into the mold, and hopefully you can also see that the adaptation has occurred in the contact region. Okay, and we could refine that further. We could use curvature or use a smaller minimum distance, but that seems like a reasonable level of refinement for this simple case. So I'm just going to run the animation here. So to do that, you can either right-click on results, go to Solution History Playback, or if you click the Results tab up here, you've got the same controls over here. So I can just run that through. Back to the start. And you can see the adaptation cycles occurring every 5 time steps. Okay, so that's the simulation completed, and I've added a contour here just to complete the analysis. I'm using contact time from the fields, and I've just selected the free surface. I've added the symmetries in. It's not going to display contact time on those, but it's just so you can see how the fluid moves around the molds here. So let's just display this. You can see you've got the contact up here. Let's reorientate that and play that through. Okay, so that is the completed pressing simulation using the ANSYS Fluent Materials Processing workspace. I hope you found this useful, and it encourages to use this feature of ANSYS Fluent. So thank you for watching, and bye for now.